Have you ever pondered what might occur if a needle collided with Earth at the speed of light? Let's embark on an imaginative journey to explore this hypothetical scenario. The speed of light, a staggering 700 million miles per hour, is a concept that our minds can hardly grasp. Now imagine an ordinary needle, thin and sharp, traveling at this unimaginable speed. To put things into perspective, let's consider some real-world events. Picture the impact of a meteorite, the sudden release of energy, and the ensuing chaos. Now amplify that 1,000 times over. That's the kind of force we're talking about. A needle, despite its minuscule size, traveling at the speed of light, would carry an astronomical amount of kinetic energy. The consequences? Well, they'd be nothing short of cataclysmic. A tiny needle, unassuming and innocuous, could potentially wreak havoc on a scale we've never witnessed. Just imagine, a seemingly insignificant needle causing such a massive catastrophe. But first, let's demystify the speed of light. Now imagine if you could circle the Earth 7.5 times in just 1 second. That's how fast light travels. It's a speed so unimaginably swift, it's used as a universal constant in our laws of physics. Imagine the fastest thing you can think of, maybe a cheetah or a supersonic jet. Now imagine something that makes those look like they're standing still. That's the speed of light, approximately 670 million miles per hour. To provide a bit of context, let's use an analogy. If a snail were to start a journey from the Earth to the Sun, it would take about 175 years to complete. But light? It takes that journey in a mere 8 minutes and 20 seconds. According to Einstein's theory of relativity, nothing in the universe can travel faster than light. It's like a cosmic speed limit. The closer you get to this speed, the more energy you need, and to reach it, you'd need an infinite amount of energy. That's because, as you approach the speed of light, your mass increases, making you heavier, and thus requiring more energy to keep accelerating. This is Einstein's famous equation, E plus mc2, in action. So, if we could somehow propel a needle to this unimaginable speed, what would be the outcome? Now, let's delve into the consequences of our needle hitting the Earth at light speed. You see, when an object is moving at such a high speed, it carries with it an astronomical amount of kinetic energy. This energy is the product of half its mass times the square of its velocity. So even if our needle is incredibly small, its velocity, being the speed of light, means that the energy it holds is colossal. Now imagine this needle colliding with our planet. Upon impact, all that kinetic energy has to go somewhere, and that somewhere is directly into the Earth. This energy transfer would cause a massive explosion, the likes of which we've never seen before. Just to give some perspective, it would be many times greater than the largest nuclear explosion ever recorded. But the destruction doesn't stop there. The explosion would not only obliterate everything in its immediate vicinity, but it would also send shockwaves rippling outwards, leveling cities and forests alike. The heat generated from the explosion would be so intense that it would ignite massive fires, turning vast areas into infernos. The shockwave would also trigger seismic activities, leading to catastrophic earthquakes. These quakes wouldn't just be localized to the area of impact, but would be felt around the globe, causing widespread destruction. And let's not forget about the tsunamis. The impact would displace an enormous amount of water, causing titanic waves to radiate out across the oceans. These tsunamis would wreak havoc on coastal areas, washing away entire cities and causing untold loss of life. This is not to mention the dust and debris that would be thrown up into the atmosphere, blocking out sunlight and leading to a nuclear winter-like scenario. The Earth's climate would be drastically altered, and life as we know it would be devastated. All in all, the impact of a needle hitting the Earth at the speed of light would be cataclysmic. The destruction it would cause, the lives it would take, and the changes it would bring about to our planet are unfathomable. The aftermath would be nothing short of apocalyptic. But what would happen after the initial impact, you might ask? Well, the aftermath would be as dramatic as the impact itself, if not more. Following the immediate shock and devastation, the planet would have to grapple with long-term effects. One of the most immediate and threatening would be the massive amount of debris thrown up into the atmosphere from the impact. This debris would act as a dense, sun-blocking veil, plunging the Earth into a state akin to a nuclear winter. This phrase, nuclear winter, is a term scientists use to describe a theoretical scenario where soot and smoke from widespread fires block out sunlight, causing a significant drop in temperatures worldwide. This would not be a brief, temporary condition but could persist for many years, even decades. And what about life on Earth? The sudden and drastic change in climate could trigger a mass extinction event. Species unable to adapt to the new harsh conditions would perish, while only the most resilient would survive, forever altering the planet's biodiversity. Furthermore, the profound changes to Earth's climate would not be limited to temperature alone. Changes in precipitation patterns, ocean currents, and wind circulation could drastically reshape the planet's geography and ecosystems. So, while the premise might seem far-fetched, the results of such an event are a sobering reminder of the power of speed and mass.